Alright, so we're going to discuss ellipses. So ellipses are kind of like a football shape or an oval. Okay, they're not a complete circle. Okay, and so the first thing we're going to talk about is how to find the constant sum. So the first thing you'll do is find the distances between the point on the ellipse and each focus, and then you're going to add those two distances together. So here I've given you one focus, another focus, and by the way, those are inside your ellipse. Okay, and then I've given you a point on the ellipse. So if you will recall the distance formula, that's where you take and subtract your x's and square that. And you take your y's and subtract those and you square that. And then you add those two things together and take the square root. So what we're going to do is we're going to find the distance between the first focus and the point, the second focus and that point, and then you're going to add those two distances together. So with that being said, let's start with the first focus. So I have the first focus and this point. So this would be like my x1, y1, and this would be x2, y2. It doesn't matter which one's the x1, which one's the y1 really. Alright, so I've got 0 minus -3 squared plus 4 minus 0 squared. And if I work that out, that's going to give me 25 underneath, and the square root of 25 is 5. And then I have to add that to the distance between my second focus and that point. So focus number 2 and that same point on the ellipse. So again, if I use x2, y2, this is going to be x1, y1, x2, y2. So I've got 0 minus 3 squared plus 4 minus 0 squared. That's going to give me the square root of 25, which is 5. If I add those two things together, 5 plus 5 makes 10. So the constant sum would be 10. And I'm only going to give you one of those. Okay. I feel like that's pretty simple to catch on to. All right. Now let's talk about writing equations in standard form. Remember, if you need to pause the video to write this stuff down, go ahead. Okay. So I'm giving you two things. These two equations, all right, are kind of the same except for the bottom parts. They both have a center at 0, 0. So you have 0, there's no number here, and 0. So that'd be a center at 0, 0, 0, 0. The only difference is that now we have these numbers at the bottom. Notice that this is always equal to 1. And the thing is, A, depending on where A is at, A will tell you if you're going to have an ellipse that is up and down or one that is left to right. Okay. Now the thing about these is these are really close to hyperbolas, which we'll talk about in the next section. But there's a difference, okay, between your A's and your B's. If A is underneath the X, then that means it's going to be a left to right one. So kind of like your x-axis goes left to right, this tells you that. All right, if A is underneath the Y, that tells you that it's a tall one or a more elongated one up and down, just like your y-axis goes up and down. Okay. The difference with these is that these equations right here do not have a center at 0, 0. They have numbers h and k, but the same thing applies with that. So let's talk about A, B, and C. A is your vertex. It represents your vertex. It's always the bigger number. Okay, always. And it's always on what we call the major axis, so that tells you which direction you're going. All right, B is your covertex. It's always the smaller of the two numbers on the bottom, and it's always on your minor axis. C is always on the major axis. So these two are always on the major axis. All right, to identify A and B, make sure that you square root your denominators. All right, that's really, 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 really important. Okay, A squared is on the denominator. B squared is in the denominator. So make sure that you square root them to find the actual A and B. And here's a little formula. If you have two of them but need the third, it's A squared minus B squared equals C squared. Kind of like the Pythagorean theorem, but instead of A plus, we have a minus. So this is going to come in handy when you're missing A or B. Okay? We don't need C to write an equation, but we do need A and B. All right, let's write the equation in standard form. And all of these are going to have a center at 0, 0. So if you want to write that down, center at 0, 0, that'd be great. I'm not going to make you write any that aren't. So here's the thing. We know that the vertex and the focus are always on the major axis. Okay? And so when you're looking at this, look at the non-zero number. So if you look at the vertex, the non-zero number is in the x position. And so is the focus. The non-zero number is in the x position. That tells me that the bigger number is going to go underneath my x. So when I write this equation, I already know the center is at 0, 0. So I know that I'm going to have x squared over something plus y squared over something is equal to 1. The only thing I don't have are A and B. So I know that the vertex always tells me the A. Okay, so I know that A is 10, or negative 10. All right, B comes from my covertex. I don't have a covertex here, so I don't know what that is. And I know that C comes from my focus. It's the non-zero number since we're at the center. So this is 8. I have to have B in order to plug in up here. Now, since this represents my A, okay, my vertex, this is going to go underneath the X because it's in the X spot. But remember, this is A squared. So I know that A squared is equal to negative 10 squared, which is 100. So that's going to go underneath the x. I know that this has to be b squared. Well, I don't even know what b is yet. So I need to figure out what b is, and that's where this little formula comes in handy. The a squared minus b squared equals c squared. So let's plug in for what we know. Well, I know that a squared is 100 minus, I don't know b, but c squared, well, if I take 8 and square it, that gives me 64. And now I'm just going to solve for b. So I'll subtract 100. So I get negative b squared equals negative 36. I have to divide by the negative 1. So I have b squared equals 36. Now, I could square root this and figure out what b is, but in my formula I need b squared, correct? So b squared is 36, and that's going to go underneath the y. So there's the equation to this problem. All right, so let's take a look at number 3. I have a vertex and a covertex. Well, my non-zero number is in the y spot for the vertex, and my non-zero number for the covertex is in the x spot. Now, if you'll recall, vertex is always on the major axis, so that means my major axis is going to be the y-axis. So when I make my equation, I've got x squared over something plus y squared over something equals 1. I already know that the a, which is represented by this right here, is going to be underneath the y, but I have to square it, right? So I know that a is 8. All right, and then I know that the covertex tells me my b, so I know that b is 3. Since my vertex is identifying with the y value as the non-zero number, I'm going to take that number and square it. So a squared is 64. That's going to go underneath the y. And then 3 squared would be my b squared. That's 9. That goes underneath the x. And I am done. All right, let's take a look at number 4. Again, center is still at 0, 0. So I notice that my vertex, the non-zero number, is in the x spot, and the vertex tells me the a. My covertex, the non-zero number, is in the y spot. That tells me the b. So when I write my equation, I know I'm going to have x squared over something plus y squared over something equals 1. All right, so I realize that a and x go hand in hand, right? This 9 is in the x spot, and the vertex identifies the a. So I'm going to take that and square it. 9 squared is 81. My b is being identified by the y spot, so I take the 5 and square it. That's 25, and I've got my equation. It's always nice when A and B are identified. Number 5. My covertex always identifies the B, and it is identifying the spot that's in the X spot. Covertex is always on my minor axis, right? Focus tells me the C, non-zero number is the C, and it is in the Y spot. Now I know that the focus is always on my major axis, so that means that my A, when I find it, will be with the Y. Focus and vertex kind of go hand in hand there. So I know I'm going to have x squared over something plus y squared over something is equal to 1. Now I already know that the B is 4, and that's in the x spot, so I'll square that. That gives me 16. But I still have to find my A. So I already know I don't know my A. My B was 4, and my C is 3. So I'm going to plug into the formula A squared minus B squared equals C squared. All right? I don't know A, so I leave that alone. But I do know that B is 4, and if I square that, B squared is 16. And then I have to square my C. C squared is 9. All I have to do is add the 16. And I could square root right here to find A, but I don't need A. I need A squared. So A squared is 25, and I have my equation. All right, let's do one more of those. My vertex, non-zero number, is in the Y spot, and vertex identifies the A. My focus, non-zero number, is in the Y spot, and it identifies the C. So I know I'm going to have an equation where I have x squared over something plus y squared over something equals 1. I already know that y is being identified on my vertex. So I'm going to take that 25 and square it. That gives me 625. That goes underneath the y. but I still need b squared to go under here. So I know that a is 25. I don't know b. And I know that c is negative 20. So I will plug into the formula a squared minus b squared equals c squared. So I know that a squared is 625 minus, I don't know b, that's what I'm trying to find. And I know that c squared is 400. Negative 20 squared is 400. So I will subtract the 625, and I have negative b squared equals 400 minus 625 is negative 225. But I have to get rid of this negative 1. So I divide by negative 1, and b squared is positive 225. I don't need b, I need b squared. So 225 is what's going to go underneath the x. All right, so now let's talk about graphing. All right, so if we look at this, the very first thing we want to identify is the center. Okay, that's your starting point. So your center is always at h comma k, which we've talked about when graphing circles. It's the same thing. So remember, it's always opposite of what it looks like. So I get my x value from the x and my y value from the y. So this is going to be a positive 3, comma, a positive 1. Then I have to decide, well, is this going to be a vertical ellipse or a horizontal ellipse? And if you look, the bigger number is underneath the y. Y is vertical, so this is going to be vertical. Should be like a standing up egg. And then I need to identify a. So a would be the square root of the bigger number. That's 36. So the square root of 36 is 6. That is underneath the y. Since it's underneath the y, that means we'll go up 6 and down 6. B is the square root of 16, which is 4. Since it's under the x, that means we move left 4 and right 4. So you'll start with your center at 3, 1. And I know I've numbered these, but I'm actually going to count by 2's. Okay? So this would be 2, halfway would be 3, and then I'm going to go up to 1, which is like halfway. I just don't have room on mine. Then we stated that from the center, we're going to go up 6, 1, 2, 3, 4, 5, 6, and down 6, 1, 2, 3, 4, 5, 6. Then we're going to go left 4 and right 4 from the center, 1, 2, 3, 4, 1, 2, 3, 4. Now I can draw this in. Now these are not pointy. If you want to round and kind of flatten out a little bit, flatten, flatten, and you have your ellipse. So if I ask for you to label your points, all right, remember whichever way it's going. In other words, this one's up and down, so this would be a vertex up here, and this would be a vertex down here, which means the ones on the side will be your co-vertices. So if I ask for you to give me the points, this would be 3, comma, 2, 4, 2, 4, 6, 7. This would be 3 comma negative 5. This would be 7 comma 1. And then this point would be negative 1, 1. All right, number 7, still graphing. Oh, did I go? Oh, this is number 8, sorry. Number 8, still graphing. So the first thing that we always identify is our center because that's our starting point, right? So there are no numbers with your x and y, so that means that your center is at 0, 0. Please remember that. All right, since the bigger number is underneath your x, that means this is a horizontal ellipse. It's going to be a laying down egg. All right, a is the square root of the bigger number, so the square root of 64 is 8. Since it's underneath the x, that means you'll move left and right 8. B is the square root of the smaller number, so the square root of 25, which is 5. Since it's underneath the y, that means you'll move up 5 and down 5. So let's start with our center, 0, 0. And again, I'm going to count by 2s on mine. I have to move left and right 8, 2, 4, 6, 8. 2, 4, 6, 8. And up and down 5, so 2, 4, 5, and 2, 4, 5. And now I have all of my outside, so I'll draw this in. Remember, I don't want pointy ellipses. These are circle things. They should be round. Ooh, that was really ugly. Okay, so if this is a laying down egg, you went farther left and right, that means these are your vertices, and the other side is your co-vertices. And to label those points, this point would be 8, comma 0. This point is negative 8, comma 0. This point is 0, comma 5. And this one is 0, negative 5. All right, let's do one more graphing problem. And then we'll do a word problem. All right, so we always start with our center. Remember, x comes from the x and the y comes from the y. This is opposite of what it looks like, so this would be a positive 2, comma, positive 4. Since the bigger number is under the x, and x is a left-right, that means this is horizontal. It would be more like a laying down egg. Okay? A is the square root of the bigger number, so the square root of 25 is 5. Since it's under the x, that means we move left 5 and right 5. B is the square root of the smaller number, the square root of 9, which is 3. Since it's under the y, that means we move up 3 and down 3. So we'll start with our center. Again, I'm going to count by 2s. So I'd have 2, comma, 2, 4. From the center, we will move left 5 and right 5, so 2, 4, 5, left 5, 2, 4, 5, and then we move up and down 3, so 2, 3, and 2, 3. And now I am ready to draw this in. I don't want something that looks pointy like a football. Remember, these should be round. Okay? Since this is a left-right and it's laying down, the sides right here on the left and right will be my vertices, and these will be my co-vertices. So if I label these points, this point would be 2, 4, 6, 7, comma, 4. This point would be negative 3, comma, 4. This point would be 2, comma, 2, 4, 6, 7. And this one would be 2, comma, 1. Okay, the graphing is pretty simple. Okay, so let's do this word problem. A road passes through a tunnel in the form of a semi-ellipse. So that means it's not a full ellipse, it's just a half. In order to widen the road to accommodate more traffic, engineers must design a larger tunnel that is twice as wide and 1.5 times as tall as the original tunnel. The design for the original tunnel can be modeled by the equation x squared over 100 plus y squared over 64 equals 1, measured in feet. Okay? So we're supposed to find the dimensions of the larger tunnel. All right? So let's write down the equation that we had to begin with. So we have x squared over 100 plus y squared over 64 equals 1. So we're always going to assume that when you're talking about a word problem that the center is at 0, 0. Okay? So let's talk about the first thing. So we have a semi-ellipse, right? Which is like, here's my road, and I have this like dome-shaped thing, right? And it told me that they're wanting to go 2 times as wide and 1.5 times as tall. So first things first, we got to figure out how wide and how tall it is. So here would be my center, right? Like center of my road. So if we want to know how far we had to go from the center out to the sides, we need to know what is underneath the x. So we have 100, and that's the bigger number, so we know that's the a, right? So I have to square root that 100, which gives me 10. So that means from the center, I went 10 this direction and 10 this direction. Now, to figure out how tall it is, I have to figure out how far I went from the center up. I have to square root the other number, which would represent my b. So I square root the 64, and I get 8. So that means from here up is 8. Now, we have to think about how wide this is. It's not 10 wide. It's actually 20 wide. Now, if they want to go 2 times as wide, and I know that it's 20, I guess is this feet? Yes, 20 feet wide. All I do is take that times 2. 20 times 2 is 40. So I know I'm 40 wide, which means that now instead of 10 and 10, it's going to be 20 and 20. It's the same distance on each side. And they want to go 1.5 times as tall, so I would take 8, that's my height, and take that times 1.5. That gives me 12. So now instead of being 8 feet tall, it is 12 feet tall. I don't have to split it because my semi-ellipse, it only goes up, it doesn't go down. Okay, if it went down, it was 12 the whole way. Then I would split it like I did halfway across. Okay. Now I have to write the equation of my new road. Well, I know that 20 is my new A, right? because that's how far it is from center to the side, so A is 20. And I know that my B is my new thing up here. It's 12. That's how far it is from the center up to the top of my tunnel. So I know that B is 12. So now all I have to do is re-input back in. So I get x squared over 20 squared. 20 squared is 400. Plus y squared over 12 squared. 12 squared is 144 equals 1. And that's the equation of my new one. All right, let's do one more just so we have a little bit of practice with this. All right, I'm going to read it to you. Engineers have designed a tunnel with the equation x squared over 64 plus y squared over 144. Oops, sorry, 36. My bad. Reading the wrong thing. Y squared over 36 equals 1. Measured in feet. A design for a tunnel needs to be twice as wide. So I'll say 2 times as wide and 3 times as tall. So let's draw us a little picture. So we have a tunnel again. Semi-ellipse. Here's the center. So I have to know how far it is from the center to each side. Well, that's a left-right motion, which is my x. So I square root the 64. That gives me 8. So it's 8 from the center out. So from here to here is 8, and from this side to this side is 8 feet. Now, how far up from the center? So I square root the 36, which gives me 6. So from here up is 6 feet. Kind of a small tunnel. All right. Is this a tunnel? Yeah, it's still a tunnel. All right. So they want it to be 2 times as wide. Well, right now, from side to side is 16. So I would have to take 16 times 2. So that would give me 32. So 32 all the way across. So I'd have to half that for each side. So that would give me 16 and 16. And then they want it 3 times as tall. Well, it's already 6 feet tall. Take that times 3 and you get 18. So now, instead of 6 feet, it is 18 feet tall. So now I'm ready to write the equation again. So I've got x squared over a squared. Well, I know that a is the half distance, right, from the center to the side. So I would take 16 and square it. That gives me 256 plus y squared over, it's 18 feet from center to the top. 18 squared is 324 equals 1. Not that bad. Just be very careful on the across part. Don't square the entire thing because that number underneath is just from the center to the side. Okay? And that's all I've got for you.